I am now checking out the instrumentation which I have set up for the measurement of charges during the 3 nails experiment. This experiment is the basis of cathodic protection network practice, because it actually shows the corrosion reaction, and within 2 or 3 hours of setting up the experiment, corrosion products can be seen to verify the theory and the measurements that have been taken during the experiment. I've set up an oscilloscope, which is a Pico Dr. DAC oscilloscope, and that is showing here, and I've set up a recording voltmeter, which is a data logger which logs recorded volts into this computer through this metering system. For the benefit of this first demonstration, I am using a copper to copper sulfate reference electrode, or ground contact electrode, or you might call it a half cell, whatever. It is a piece of pure copper wire in a saturated solution of copper sulfate. It makes contact through a piece of wood to the electrolyte, which is a dry cloth at the moment, and under the dry cloth are 3 nails. The charges come from the battery, which is here, which is 2 corrosion cells in fact, and they are discharging electricity through this connection to this nail, and that is charging up this nail with respect to the rest of the system. When I put some water on this nail, you will see that the charges start to pass through the system and return via this nail, which is connected to the other side of the battery system. So I'm just going to get some water and I will charge it up. This is ordinary tap water, and I'm using a syringe in order to put the water into the exact spot that I need it. So, you can watch the meters as I do this, and you will see the effect of the water. Now, electrical charges don't pass through water itself. if you have pure water, it is virtually non-conductive. It is in fact the salts in the water, the dissolved salts in the water, the dissolved salts in the water, and even in tap water there's a lot of dissolved salts, and the charges pass through the dissolved salts in the water. If you try the same thing with battery charging water, you will find that it isn't in fact conductive. Now, I haven't been looking at the meters to see what the changes are, but we can now lift, oops, now, the ground contact electrode, half cell or copper sulfate electrode, is on dry ground, dry electrolyte. So there's no charges being conducted there. But when I put the water, when I damp the electrolyte, you will notice then a dramatic change in both the oscilloscope and the data logger. That is because the charges complete their course and they go not just directly through this system, but they spread out throughout the whole of the electrolyte that is available, and they spread out according to the laws of Kirchhoff, which says that they will take the least line of resistance. And Kirchhoff's law of resistances in parallel explains this very well, and you can apply that formula to all the readings that you get. So that's how we work in proper cathodic protection and corrosion control. We make all these measurements, we know what these measurements indicate, and they are supported by the laws of nature that are applied universally in electronics, electricity, and all that sort of thing. So this is not new. This is just using the known and codified laws of science to reach a goal, and that is to control corrosion.